Hi, today we're going to talk about how to use theoretical or experimental probability to make a prediction. So on the screen it says, how many times can I expect to flip heads if I flip a coin 40 times? Well, a coin only has two choices, so the bottom of my fraction will be 2. Heads is just one of those two choices, so my theoretical probability is 1 out of 2, which is 50%. That means half the time, or 50% of the time, I expect that I'm going to flip a heads. I'm going to flip heads. So there are two different ways that we could solve for how many times we think we're going to flip heads in this particular case. One strategy is we could set up a proportion, 1 over 2 equals 40 with what above it, and solve 40 times 1 divided by 2 equals 20. That is one strategy. Another strategy is we can just do 50% of 40. Well, of means multiply, so it's just 50% times 40, again, equals 20. Those are two great strategies. This strategy on the bottom works the best if you have a nice whole number as the percent. If your percent is some kind of decimal or repeating decimal in particular, the top strategy, setting up a proportion, is going to be a little bit easier. But there's two strategies for solving, and we predict 20 times. That's in theory. Well, we know that just because we think in theory that should happen, it doesn't guarantee it's going to happen. So let's take a look at our next problem. I rolled a dice 20 times and got an even number 14 times. If I roll the dice 15 more times, how often can I expect to get an odd number based on this experimental probability? Well, this says that my experiment shows that I got an even number 14 times out of 20. Well, we know that half the numbers are even and half the numbers are odd. So I would have expected, based on my theoretical probability, that it would have been 10 out of 20 times I got an even number. So this experiment shows us that, well, no, we haven't actually gotten exactly 50-50 like we thought it would be. But based on what we've gotten, if I roll 15 more times, it now asks, well, how many times do I expect it will be odd? Well, this is my even probability, which means if 14 times it was an even number, then I just do 20 minus 14, which means 6 times it was an odd number. So this is our odd probability. I'm going to use this to set up a proportion. And I'm just going to solve 15 times 6 divided by 20. So 15 times 6 divided by 20, it actually equals 4.5. When I roll a dice, assuming I'm not like on a carpet where it could land on a corner, when I roll the dice, it just lands on a certain number. So I'm going to round this up to round it correctly. So I'm rounding it up to a 5. So 5 out of 15 times I expect to get an odd number. That's the one strategy, right? That's setting up a proportion. The other strategy that we could have used instead is 6 out of 20 is 30%. So we could have done 30% times 15. Again, that's going to equal 4.5, and we're going to round up to 5. So those are the two different strategies we could have used. But notice how these two things are different. Theoretical probability was based on what we think will happen. Experimental probability is based on what has happened so far. So that is making a prediction based on probability.